So here we are, we're going to look at how to find the formulas for the surface area and the volume of a hemisphere. In order to do this, we are going to use the already known formulas for a full sphere. So we do know that the volume of a full sphere is 4 over 3 times pi r cubed, and the surface area of a full sphere is 4 pi r squared. So we'll look at the volume formula first. Okay? So if I'm taking the volume of a hemisphere, you should really notice that if I just show the other half of the sphere here, then volume, of course, is how much space is inside of a shape. So a hemisphere should have exactly half as much space inside as the sphere that has the same radius, right? So if I have this whole shape, it should really have, well, the hemisphere should have half of the volume of the whole shape. Alright? So I can say, alright, the volume of my hemisphere should be 1/2 of the volume of a sphere. So I could say it's the volume of a sphere divided by 2, or I could say it's 1/2 times the volume of a sphere. They're both the same thing, right? So let's say it's 1/2 times the volume of a sphere. Okay? So then that gives us 1/2 times 4 over 3 pi r, oops, that's supposed to be cubed. Alright, so to multiply these fractions here, I would multiply numerator by numerator and denominator by denominator. 1 times 4 is 4, 2 times 3 is 6, so I get 4 over 6 pi r cubed. Then we can reduce this fraction. They're both divisible by, both the numerator and denominator are divisible by 2. So I reduce to 2 over 3 pi r cubed. So this is the volume of a hemisphere. It's 2 over 3 pi r cubed. Okay? Now, I need to look at the surface area of a hemisphere. It's a little bit more complicated than just the volume, and you'll see in a second why. So I do know that the surface area of a sphere is 4 pi r squared, so you might think, okay, so the surface area of my hemisphere then should just be 1/2 of this surface area of my sphere. And this is actually the right start to it, right? So I could say, alright, 1/2 of 4, well, half of 4 is just 2, right? So I could say, alright, I've got 2 pi r squared right here. But hopefully what you might be thinking here is when I take a sphere and I cut it in half, my sphere originally only had one face. It's just all around the circle, right? But when I cut it in half, I've actually made another face. I've still got this rounded part, but when I cut it in half, I made this face right here, didn't I? This face is now on the outside, whereas before it was on the inside of the shape. So since it's now on the outside, it's on the surface of the shape, I need to take that surface and its area into account when I do my surface area formula. Well, this shape here is a circle, so I need to account for the area of this circle that I just created. So we know the area of a circle is pi r squared, so that means I need to add on at the end the area of that surface that I just created, that circle, which is pi r squared. Okay? So my surface area of my hemisphere is really 2 pi r squared plus pi r squared. So this is the same as having 2 pi r squared plus 1 more pi r squared, giving me 3 pi r squared. So the surface area of a full hemisphere is 3 pi r squared. Okay?